So this is me on a good day. I chair the society, and so can help you guys out with whatever you want. I'm currently doing my PhD. I'm in my 4th year, so I don't have a lot of time. But I want to help you guys as much as possible. I also love pina coladas and walks in the rain. So moving on. Basically, the challenge this year, I was hoping we would build a maze solver. It's quite an intricate robot. Basically, runs around a little maze like you might see here, finds the quickest path out, and usually it's a competition. You can Google these things, and they're really, really cool to watch. And so basically, the reason we're going to do it is because it involves quite a bit of kind of coverage on what we learned and covered in boot camp. So it has a moving chassis. So, you need obviously a base with wheels. It needs to be able to maneuver around the maze. You need sensors or some sort of system for guidance to figure out where the walls are. So you don't just hit them, but you also navigate your way around them. And then finally, on top of that, you could send in your robot with lots of sensors into a maze. But if it doesn't have the correct algorithm, it's just going to find itself in a dead end, or it may never get out. It might just be like a mindless zombie. So there's quite a few features that we're doing in this, and throughout the weeks, I wonder if that's going to work. Yes. So this week we're going to be covering a bit more of Tinkercad to get you guys familiar with the components. Now, I've had to break down the week plan. We'll only be doing this for about a month or so, depending on how you guys feedback from this. I wanted to kind of send out packages for you guys to build these yourselves at home along with me. That was kind of the plan. Unfortunately, because of lockdown 2.0, we're all in a little bit of a pickle with that one. So I'm not going to be able to do that. I'm going to see if I can put your faces over here. Sorry. Boom. Okay, I've got 2 cameras. Yeah. So unfortunately, we can't do that. And then I looked at the opportunity of you guys buying your own kits. Turns out electronics is quite expensive, and the kits came about £50 each. So I'm not going to make you guys do that either. So what I'm going to do is I'm basically going to guide you through how to design everything for a maze solver. We're going to cover Tinkercad and the components in week 1. In week 2, we're going to use a fun little software from one of our sponsors that I can show you in a little bit to figure out the kind of algorithms, and you'll learn a bit of block coding. In week 3, we'll do some 3D design and 3D printing. So basically looking at whatever you guys want to build. I'll be looking for suggestions up until then. Otherwise, it's most likely going to be a ramp for a sumo bot. Anyway, so week 3, I'm open to suggestions. Post things that you want to learn how to 3D print or problems you have with 3D printing, and I will manage that. And week 4, we're either going to look at Python or JavaScript, so a different type of programming. And we're going to do a little competition on the maze solving robot using the Roboton.io software. This will all become clearer in the later weeks. Is everyone happy with that? Can I get hands up on the teams if you're happy with everything I've just said? Little boopty hands. Fantastic. That's so much fun. Yeah. Okay, cool. So that's what we're going to try and do. So how many of you, okay, lower your hands. How many of you were at boot camp and covered circuits with me? I need you to put your hands up if you have. Okay. So we've got about half and half. Right, okay. So firstly, guys, I'm going to need you all to go to your web browsers. It's not a problem if you can't follow along with this, but it's obviously best if you can. I need you to type in Tinkercad. Just like that. Enter Tinkercad, and you'll come up to a home page. I'll log out like this. Again, can I get hands up if you've got to this page? If you can't follow along, the session is recorded. You can then do it in your own time, but you can obviously learn from watching. Okay, is anyone not here yet? That's probably the best way to do it. Hands up if you're not here yet and need more time. Okay, so you're going to sign in. If you have a Fusion 360 account already, so you've used Fusion or Tinkercad, you can sign in. If you don't, join now, and you can find it. It's just really quick. It shouldn't take too long. I'm going to sign in with my Fusion 360 account that I use on Autodesk. Boom. Don't look at my passwords. Haha. Okay. Tinkercad is essentially the software we're going to use. It's not perfect by any means. I've had a lot of trouble with it, but it does cover the basics. It allows us to do some programming on circuits, which is what we're trying to look at here. And basically, as soon as this whole project's over, and as soon as we're allowed to go and meet up in spaces and whatnot, I will be providing you guys with kits. And then you guys will be able to go ahead and make these robots yourself, either in your own time, or we'll do like a end of term 2 kind of based thing. But I want you guys to build this, so we'll cover all the theory and the coding and the practice, and then you guys can actually take some kits away at some point during the year, probably mid-December or later, and then you guys can go ahead and build these for yourself and see how it actually works. Does that sound okay to everyone? Yeah, of course it does, because it's sick. Right, so once you're on this page, I'm hoping everyone's here because I've waffled long enough. We're going to go on to circuits here on the left. Okay, you're all going to go to create new circuit. I'm not, because I've already practiced. Okay, so hopefully everyone is loading up a wonderful screen that doesn't have a pre-made circuit. Let's ignore that. Don't look at it. Okay, hands up if you're not here yet and I need to waffle on for a little bit. No, cool, fantastic. Right, so back to our presentation. I'm going to rattle through this as quickly as possible because most of this is covered in bootcamp. If you weren't at bootcamp, I strongly advise that you go back through week 2 of bootcamp, which was all circuits based, and we will cover this. Anyway, LEDs, light emitting diodes, will only allow current to flow through one way. This is what they look like. They have a long leg that we connect to positive and a short leg that we connect to negative. Basically, throughout all of these, I will call things negative, 0 volts, low, ground, whatever, means the same thing. I will call all positive, high, 5 volts, VSS, supply. You know, they're all the same name for different names for the same thing. The resistor, we have to apply a resistor to limit the current that's going to go through our LED. We don't want to blow it up, so we use a resistor. Again, all of this was covered in bootcamp. Breadboards, okay? Breadboards, and I'm going to explain all of this, don't worry. Breadboards are basically clever ways for us to connect everything up simply so that we don't have loads of wires going everywhere. Connections for breadboards look like this. You have long horizontal connections indicated by lines down here, and you have short these are horizontal, those are vertical connections along here. Tinkercad will explain this to you. So if I go over to my beautiful breadboard over here that we're all going to make, you can see that any connection across this line is highlighted, and any connection across these lines are vertical, are also highlighted. Yay for Tinkercad. Anyway, now we're going to go over some Arduino syntax. Okay. So this is an Arduino. It's now going to be your new best friend for today's session. And essentially, it's a little board, a little electronics board, and we can program it to control inputs and outputs. So it's got all these pins down the side here, where normally you would plug in wires, and they're numbered 0 all the way up to 13. And these can be digital input outputs. Does anyone not understand what I mean by digital? Raise your hand if you don't understand. Please don't be shy. Right, Tarek. Okay, thank you. So digital just means it's either on or off. Okay, it's either high or low. It's either 5 volts or 0 volts. There is no in between. Okay, so you send a digital signal and it's like it's 0 volts and then bam, 5 volts, then 0 volts. It kind of looks a bit like this. Okay, this is a digital signal. Right, sinusoidal or analog would be kind of in between. It can be at any point in between. Anyway, so we can read on these pins 0 or 5 volts because the Arduino focuses on 5 volt logic, and we can also output 0 or 5 volts digital pins. We also have USB connection, which we use to connect it to a computer to program, and we also have these little pins here called PWM with this little wiggly hyphen in front of it. Also, if I'm starting to lose anyone, talking too fast or over explaining things, please just let me know that you've seen this before and I'm putting you to sleep. Okay, again, I want some feedback from you people. as well as this PWM that I'm going to explain a little bit, you have some 5-volt outputs and some ground connections. Remember, ground is 0 volts or whatever. And you can see ground here at the bottom and 5 volts. You've also got 3.3. And these are all what we call female headers, which mean that they're basically holes that we can put wires in. And you also have these 5 analog input pins. Okay. Anyway, this is the Arduino, and I'll explain it as we go. Pulse width modulation is something important to understand. Tarek, you can also put your hand down if you want. Pulse width modulation, basically, we can only put high or low signals output or input to an Arduino because it has 5-volt logic. Okay. However, PWM is a clever method that they've come up with so that we can manage these discrete voltages. So we can have basically we turn it on and off really fast. So here you can see that we've got it on for a very, very small amount of time. The average voltage is therefore very, very low. We're basically switching lots and lots of times, and we turn it on for a very small fraction of that time. Alternatively, we can have it on for a very, very large amount of time and off for a very short amount of time in this cycle, T cycle, this time. And here we have a higher average voltage. Okay, so it's not constantly on. It's not always 5 volts. It's not constantly off. It's not 0 volts. It's just pulsing in between. And it's changing so much that the average voltage is kind of either a little bit lower or than 5 volts. So this basically... Hello, Tarek. Yes.
Sorry. Yeah, could you slow down a bit? Like you're moving too fast. So
oh, no problem.
Okay, thanks.
Okay. So basically, PWM will give us the opportunity to not only send 5 volts or 0 volts, but it will give us the chance to send signals in between. Okay. And this is only achievable from pins that have this squiggly line. So 11, 10, 9, 6, 5, and 3. These are the only pins that we can do PWM signals out from. Okay. Is everyone happy with that? No one? Anyone confused? Please put your hand up. Okay. Right. So very simply, we're going to make this circuit. I know it doesn't look like much, but essentially we're going to use the Arduino as a power supply to connect this circuit. So we've got a power supply here. We're going to go through a resistor. We're going to go through our LED. We're going to light it up. We're going to put a current through our LED, and it's going to light it up. Okay. So now let's all go to our beautiful circuits over here. I'm going to have to get rid of that. So we're all on Tinkercad. I want you to search in this library of components. I want you to get a resistor, plop it down. I want you to get a LED and plop it down. And then I want you to scroll down and get an Arduino and plop that there as well. Okay, everyone with me? Cool. You're also going to grab a small breadboard, okay, one like this, and click and drop that onto your board. Okay, this is the best thing we can do for kind of hobby electronics at home. So you can basically, if you click anywhere on one of these holes, you will start drawing a wire. Okay, so I guarantee half of you have started fiddling with this already. But essentially, we want to kind of maneuver this correctly. Here, we're going to put our LED across 2 tracks. Okay, so I'm going to put it here like so. And so here you have this anode connected like this. I'm not going to go over too much of this because we've already seen it before. But I'm going to take my 5-volt rail from my Arduino. I'm going to form a little wire, and I'm going to connect it to this rail here, my positive line. And then I'm going to color it red. Okay, fantastic. I'm then going to take the ground line from here, and I'm going to connect it to this rail. I'm going to connect that and color it black. Okay, hopefully you're all following along. Let me know if anyone needs me to slow down on my line drawings. Finally, we're going to take our positive signal, and we're going to apply our resistor across here. So can everyone see we've got our 5 volts going through this line, connecting along to the bottom of our resistor, and now our resistor is connected here. Yeah? Then we're going to take our LED, we're going to place it along this line so it's connected in line with our resistor, Make sure it's the anode that's in line with our resistor. And then we're going to take this one here and we're going to connect it to the ground line over there. Okay, so basically all we've done is we've made a little loop, goes through our resistor, lights it up. Now, if you start your simulation, your LED should light on. Okay, start your simulation at the top here. Is anyone not getting their LED light on? I will give you a minute to catch up. Tarek, how can I help?
Please, why is it connected to the ground, to the GND?
Okay, so if we take a look at this circuit here, you always have to have what we call a closed circuit. A lot of this was covered in our boot camp. So if I do lose your endpoint, you can go through it. Basically, you have to have a closed circuit. Imagine if I didn't have this connection to our negative, our ground, this would just look like a straight line. And the current needs to flow all the way around. This is basic kind of like electronics, understanding of electrons flowing.
Oh, okay. So the negative means a GND, ground.
Yes, exactly.
And positive is 5 volts.
Exactly. So where was I? Here.
Okay.
Negative, ground, GND, 0 volts, whatever. This is all the same. Positive, I'm going to use these names a lot, but I'm going to interchange them. So
Okay.
I am just warning you here. So yeah, one thing I want to show you guys is that you could have done it. Here we go. You could have done it various ways because obviously it's up to you how you want to connect everything.
Will the slides be uploaded on?
All the slides will be uploaded along with the presentation, so you don't need to worry about too much.
On WhatsApp or where?
It will be on our YouTube, and I'll put the presentation up in our Teams.
Okay.
Everyone okay with that?
Yeah.
Fantastic. So does anyone not have their LED lighting up?
If you don't, do post it in the chat. Just take the snipping tool screenshot. So on Windows Shift+S, highlight, and then just post it in the chat. I can look over it.
Post in the chat if you have problems. Okay, I want to see some colors. Tell me if you do have the LED lighting up. Okay, so back to our presentation. So we've managed to connect an LED. Yay. But now we're actually going to involve the Arduino, right? Instead of just having our LED on all the time because we've connected it to a power supply, we're going to use our Arduino to control the power supply. Okay, this is going to allow us to essentially turn the LED on and off. Okay, because we can program the Arduino output to either send a high volt 5 volt signal to the LED and turn it on, or we can tell it to not turn a signal on, right? And tell it to just send nothing, and that will close the circuit. The LED won't turn on. Okay, does anyone understand the premise of what we're going to do? We're going to blink an LED, people. It's going to be nuts. Okay, so this is the process. We're going to turn our LED on. We're going to wait half a second. We're going to turn our LED off. We're going to wait another half a second, and we're going to loop over and over. This is going to be on and off blinking. Okay, very, very fun. I know this sounds boring, but this is just covering the basics of syntax. It's not actually what we're going to be doing. And this is what we call pseudocode. I would recommend if any time you are writing a code or a language, you consider writing down pseudocode. This is like the theory of what you want your program to do. Anyway, so going through syntax, in here, we now have an Arduino on our system. So when we go here, we can collect code. Okay, when you click on code, it's going to come up with blocks. I want you to change blocks to text. Okay. And yeah, I'm on second Arduino. Right, so here you see, this is the programming. This is what we're going to tell our Arduino to do. Okay. So back to my presentation where I've got some jazzy slides to tell you why. There are 3 kind of key points that you need to know about Arduino. One is we'll have the declaration stage, we have the setup stage, and then we have the loop stage. There is a 4th, I'll introduce it later. So at the very first, we need to declare, because our Arduino is mindless, it has no idea of what's going on. We need to declare first that we have an LED. Okay, so what we do is we declare int LED equals 3. Okay, now I'm going to break this down. Int, this beginning bit, is the type of variable. An integer is just a whole number, 1, 2, 3, 4, 5, 6. Okay, so we're just saying int, we're calling an integer. We're giving our LED a name. You can call this anything you want, Bertie, Sally, Lucy, John. Okay, We're then going to assign this LED to a pin of our Arduino. I've assigned it to pin 3. Okay, you can assign it to whatever pin you want. Then we're going to whack in a semicolon. Now, I don't really understand the full reason for that, but it's basically like a full stop at the end of your sentence in programming. So always have a semicolon.
I mean, I'm guessing they use it instead of a full stop because if you have like 3 point something, you might be expecting a decimal number.
Yeah, but I don't know the full reason why it's necessary.
Yeah, no,
to be
neither
fair.
do
I think I've done a bit of assembly before. What we used to do is we used to put semicolons if we wanted to make a statement afterwards. So all of the text that is like where it says / us declaring our LED, etc. That basically you could type anything after that and it doesn't try and think it's some code that it's meant to do. So a semicolon just means you can tell someone else what that line is meant to do. I don't think it's essential to do that. It's just if you want to comment, basically, yeah.
And then finally,
like saying the statement is over.
Sorry, what was that?
Basically, with the semicolon, you just say that the
command
is over, and the code can move on to the next line.
Yeah.
Okay.
Right?
So
it will do it by default anyway. But it's like if you want to like put a comment in afterwards, like in English rather than code.
Yeah.
It just
Oh, okay.
All you need to know is basically just whack in a semicolon after pretty much every sentence. And then
it's safe to do that,
you're going to have 2 slashes. 2 slashes basically allows you to leave a comment. So this is useful for just explaining what that line of code does. Okay. Very often, this is just an important thing for you to know what your code does because you might forget about it next time you look at it. Anyway, so I want you guys to all write this in with me into your thing here. At the very top, this is our declaration. We're going to write int. I'm going to call mine LED2 equals. And we're going to take the positive side here. We're going to delete this wire. Okay, if it will allow me. Okay, no, fine. We're going to take that wire. And I'm going to connect it to pin 2 just to be difficult. Okay. Right, so I've connected my wire to pin 2. So I'm going to call LED is connected to pin 2. I'm going to leave a semicolon. Boom. We've done the declaration. Has everyone done that? Thumbs up or hands up if you have.
Sorry, Doctor, can I ask one question?
Yes, please do.
Because on my screen, just show me on the first line is the void step up. How can do I need to
just put a line extra, just like enter.
Just enter. So
just enter. So just go in front of void setup and just click the enter key.
So can I just go like the start from the line 12?
No, it's best to. I mean, yeah, no, it's best just to make yourself some space. Just
okay. I think I really need everything and just this code.
You can just put the and you can just enter a new line.
Okay. Let me see. Cut.
I was trying to set it up. Can you tell me how do we move in after the blocks? Like once we choose code.
So once you've clicked code, top bit here to click text.
I don't find an error, like a drop-down box there. Probably.
Yours doesn't have.
Oh yeah, I get it.
Yeah, you got it.
Because I was patient.
No worries. Okay, is anyone else having trouble? We all good? We all at this point?
I pressed the enter, but it's nothing happened.
Nothing's happening?
Yeah.
So you can't enter new lines like I'm doing here?
Yes.
Okay, well then, yeah, delete the rest of this and we'll write it up together. But just start with int LED2 equals 2. Okay?
Yeah, I think.
Right. I'm going to move on because I know that some of you are probably wondering, why are we learning this? But it's just syntax. Variable types to know. This is just a useful hint. We chose integer because our value of our LED is either 0 or 1. It's an integer. Okay? So int3, blah, blah, blah. You can also have long, float, double, bool, lots of other things instead of int. And these are what they mean. But we're not really going to bother with it too much during this session. Variable names. Now I said you can call it Bert, Sally, John, whatever you want. You can call LED thingy, but there are rules, okay? Names cannot have a space, so it cannot be my space LED, right? That's 2 separate things. You can use an underscore if you really want. Names cannot have punctuation. Oh, right, yeah, they can't have punctuation. They can't have special characters in them, okay? They can just be text and numbers. Also, if you call LED like this, later on, if I try and call it, I can't call it like this. LED2 is not the same as LED2, okay? Those are two separate names because of the capitals. So pay attention to capital letters in your code names. They have to be exact. Anyway, moving on. Setup. So the setup is going to happen between these hyphens. So this is a function, okay? And void setup is essentially the function you see. And that will happen once, right? So your code will initiate, and then this, the code in between these brackets here is going to happen once, okay? And everything must be contained. Everything in setup has to be contained between these two curly brackets. So here you can see we've got two curly brackets here. Everything has to be between that, okay? So you can enter some new lines there. No, don't want to open Spotify. Right, so what we're going to do now is our Arduino knows that we have something connected to pin 2, okay? But it doesn't know what it is. It doesn't know whether it should be reading signals on pin 2 or outputting signals on pin 2. So we're going to use the function pin mode. Has to be capital M in pin mode, by the way. Then we're going to declare the pin number. So we've assigned it the name LED. Pin 2 is now called LED, comma, output, okay? And then ending with our semicolon. So writing that together, everyone. Get rid of Spotify. I don't want you seeing what playlist I listen to. Pin mode, don't put a capital O. Pin mode, LED 2, remember the exact name, and then all in capital letters, you're going to put output. Okay, we've assigned that as output. Everyone happy with that? Anyone struggling? Everyone think I'm going too slow? It will pick up, trust me. Okay. Moving on then. The loop stage, right? So finally we have this third segment, the loop. And as you can imagine, it's pretty aptly named for its purpose. So that's just going to constantly loop over and over and over and over again. And one thing to point out is that the codes in this language, Arduino C++, and pretty much most of them happen sequentially. So it's going to read all of the lines 10, 11, 12, 13, 14, 15. Then in the loop, it's going to go back 10, 11, 12, 13, 14, 15. Okay, so we're going to use the new function digital write, capital W. Please pay attention to that. This function assigns the digital output high or low to the assigned variable or pin. Okay, so here we're going to use digital write. We're going to turn our LED, we've called it LED2, we're going to assign it high. That's going to send 5 volts output, right? It's going to turn it on. We're then going to use the function delay. Okay, delay is literally a pause in the code. So it reads the code, it reaches the delay, and it will wait. Okay, the delay is in milliseconds. So obviously 500 milliseconds is... Come on, people, I need some interaction.
0.5.
0.5 seconds, thank you. Okay, so we're going to wait for 0.5 seconds, half a second. Then we're going to turn our LED off. We're going to go digital write LED low. We've turned it off because we're sending 0 volts through now. And then we're going to put in another delay, and it's going to loop over and over and over again. So let's all write this together. Digital write, pay attention to that capital W, LED 2. Make sure the name's exactly the same. This bit has to be in capitals. High and low must be in capital letters, okay? This is what I mean by syntax. I could just let you guys loose on this, but it would be nuts. Delay semicolons, remember? Also, if anyone is smart, they'll probably just copy and paste this code and then just change this to low. Okay? And boom, here we have some very, very trivial code. And then once you start your simulation, we should see our LEDs flashing. Can everyone give me a big thumbs up or a hand or something if they see the LED flashing? We've understood the syntax that we're going to use throughout the whole thing. Now let's kind of make it a little bit more enjoyable. So in summary, this is what you'd actually do if you're doing it on a proper Arduino. But here we've got our variables, so our declaration, we go to our setup, and then it's going to stick in our loop, and it's going to loop over and over. Right, now actually planning for our project, people. So we are going to build these kind of creations, these maze solvers, and they're going to look beautifully, exactly like this 2D representation I've made here. No different, okay? So here you can see we've got some distance sensors here in green, and I've put in lovely little demonstrations of which way they're facing. So we're going to put on distance sensors. These are going to tell us if there is a wall in front of us or to the side of us, okay? Very simple. We've got motors here in yellow that are connected to our black wheels, and these are going to allow us to drive forward, drive backwards, turn on the spot, whether they turn forwards or backwards, okay? We're also going to use a H-bridge circuit, which if you were at boot camp, you will have experienced already, to control these motors. And then we're going to have an Arduino, obviously, to do all the inputs of the sensors and output to the motors. And we're going to whack on a battery, obviously, because you need power. Things don't just run off the will to live. Right, so here we go. Controlling the outputs. So first thing we have to do is we're going to control the motors, okay? Controlling the motors. Who has never heard of a H-bridge before? Who needs me to summarize this really, really quickly? Put your hand up. Okay. Thank you. Right, so H-bridge, this little chip here, Ali, don't you test it. Not Ali.
Prince.
Oh, Prince, damn it, the other one.
Oh, what's a mistake?
Right, okay, so guys, basically, we're going to use the H-bridge here. I'm looking at one half of it. I'm going to show you it as well over here. Oh, good Lord, this is going to kill me. Okay, this is our H-bridge. Okay, it's a tiny little chip, and it basically has all these little pins on the side, and all of these pins control or read an input. Okay, and here you can see that same pin out, so what these pins are connected to here. So here we have two in the middle are connected to ground, 0 volts. One at the top is connected to 5 volts. The one at the bottom is our power to the motors. Then you have your green ones, which connect to the motor itself, okay? And then you have input 1 and input 2. Input 1 and input 2 allow us to control the direction of the motor, okay? This was all covered in boot camp, so feel free to recap that as well. So we're going to use input 1 and input 2 like so. If we send 0 volts using our Arduino, you can see where we're going. If we send 0 volts to input 1 and input 2, the motor isn't going to do anything. Okay, the motor's going to stay still. If we send 0 volts to input 1 and 5 volts to input 2, we're going to go forwards. If we reverse that, we're going to reverse it. Very simple. And if we send high and high, 5 volts to both, it's going to stop as well. Okay? Everyone happy with that? We're basically going to control the direction of our motors by sending signals to these two pins. Yes, Ben, we love it. Yeah? Okay, fine. Yes, Ali, that's what we're about. That's what we want. A little bit of a raise. Okay, so the pseudocode that we're doing for this, again, trying to get you guys in the spirit of thinking about what's going to happen. The target is we're going to set our motors to turn for 1 second, stop for a second, and then reverse and do the same thing. Okay, from there we can find out which direction we're sending our motors in. So this is basically what we're going to do. We're going to send, remember we've got this on the other side here. Wow. Is the other side. This will control the right side, the second motor, and this controls the first motor, right? Wow, nobody even saw that coming. Okay, so I have to make this fun for myself, please. So basically, motor 1 and motor 2, motor 1 has motor 1 and 2 enable, and motor 2 has motor 2 enable. Okay, so here we're going to set int 1, 2, 3, and 4, high and low. This should basically, if we have a change, an opposition in our motors, it'll spin one way. Remember, because if they're the same like this, they're not going to do anything. So if we have a difference in them, it's going to do something. And then we're going to set them all to low, and that's going to turn them off. So in our declaration, and now this is how Bran wrote it. I'm not so happy with this. in our declaration, we first need to tell the Arduino. First, let's actually make the circuit. Come on then. Let's all go to Tinkercad. Right. So I want you guys to stop your code here. I want you to grab your breadboards that you've got up in the corner over here. I'm going to cheat slightly because I've already got my circuit made, so I'm not going to wait for you guys. So here we've got our breadboard. You're going to need to type in here motor. Okay. When you've typed in motor, you're going to find H-bridge motor driver. Okay, this L293D. That one, you can drag and drop. A little trick for anyone that hasn't used Tinkercad: if you want to select a component and then press R, it will rotate. So you can rotate it onto your breadboard. You can also use this button up on the top left to rotate. Okay. All right, and then I want you to grab a hobby motor like this and drag it into your circuit. And then I want you guys to recreate this monstrosity. Okay, so I'm going to give you all, let's say, 3 to 5 minutes to get that done. There will be prizes, a little race going out for anyone that can finish it first. The prize isn't anything material, just before you all get far too excited. I know this is basically the one part that I ask you guys to do a lot of independent learning. So this is the one point where it's a little bit of a challenge. And some of you would be like, why am I doing this again? I'm just going to keep waffling while you do your circuits. We're doing this because when you actually get round to getting your practical kits, yes, Kai. When you actually get round to making your practical bits, because I will be giving you kits at some point as soon as I can physically get my hands in the lab, or lockdown isn't stopping me, before Boris beats me up. As soon as we can, you guys will get circuits that will literally have these components, and you will be able to make this exact thing. Okay, so if you haven't already, please use the image in the comment section. I'm going to move on because we've got lots to do. So in the code section, we're going to first define our pins. We're going to tell the Arduino that we have things connected to our pins, okay? And we're also going to enable on our, here we've got our enable pins, which allow us to control the motors, and that's going to allow us later to control speed, but don't tell everyone. Okay, so we're going to go to our code here, and we're going to delete everything that we wrote before because it's stupid. Serves no purpose anymore. Right. Okay. In our code, we're going to write int, and I'm going to call them motor left 1 and motor left 2, or ML1. And I'm going to assign ML1 to pin 3. Actually, no, that doesn't make any sense. Look at your connections. My left motor is controlled by these purple ones. So my left one is 5, semicolon, int motor left 2 equals 6, semicolon, int motor right MR1 equals 3, and int MR2 equals 4. Okay, does everyone understand why we've used these numbers? Oh, also, you can all drop your hand.
Could you just repeat these steps? A bit lost.
Yeah, no, that's fine. So basically, what we're doing is just the same thing we did before with the LED.
Yep.
Look at these transferable skills. We're now declaring the pins here that we've connected to our control pins. So these pins here, these purple and green ones, are going to control our left and right motor. The purple ones are going to control the left one here. The green ones on this side of the chip are going to control this right side motor here, okay? So what we're going to do is we're going to tell the Arduino that we have things connected to pins 3, 4, 5, and 6. Okay? So once again, we're declaring integer. We're giving it a name. I've called mine, for reasons of speed, motor left 1 or ML1. You can use any name you want.
Sorry, babe, can you zoom in the code?
Oh, sorry. Is it too?
Thank you.
Yeah. Is that better? Oh, is there any way I can zoom in on the code, but not on the actual? Oh, yeah. Okay. Okay. That's probably easier for everyone, isn't it? Right. Okay. So we've declared our pins. I'm also going to declare No, we're not going to declare that. We're going to leave it for now. Right, then we're going to go to our setup. Okay, our setup here, we now need to tell the Arduino what those pins are. Okay, we're going to declare all of the motor pins as outputs. Okay, because we're going to send signals from the Arduino, right? Okay, so again, here we are. We're going to say use our fantastic pin mode function that we learned earlier with the Arduino, and we're going to label motor left 1 as an output. Okay, those of you that are savvy will probably copy and paste this code. Okay, and then you just change these to motor left 2, motor right 1, and motor right 2. Okay, so everyone should have something like this. Does everyone understand why we've done this using my beautiful LED model from before? Okay, now in the loop function, remember what we want to do. We want to run all the motors. We then want to wait 1 second. We want to stop all the motors. We want to wait another second. Okay, so we're going to use this code here. We're going to use our digital write. We're going to set motor left 1 high, motor left 2 low. Okay, as long as these are different, the motor should spin. Then we're going to send our right motor. We're going to send motor right 1 and motor right 2, 1 high, 1 low. You can switch these round, but it's just easier to copy me. Then we're going to add in a second delay, which is obviously 1000 milliseconds. And we're going to then set them the other way around. This is going to make them spin the opposite way. So actually, it's not doing what I've said it's going to do. Ignore that. Okay, so here in the void loop, we're going to go digital capital W right motor left 1 high. All capitals, remember. Semicolons, don't forget those. Again, never underestimate the importance of copy and paste.
Your L's are lowercase on ML.
Oh, yeah, thank you. Glad someone's watching. That was a dig at all of you, by the way. Oh. Right, and then just change these names to match the names that you've written before. Okay, and then set these two to low. Okay, is everyone following? Everyone understand what I'm doing? Everyone bored? I'm trying to make this as fun as possible, people. Please. Whacking in a delay. And then you're just going to swap these around. Okay, so these are just alternating. And remember what we learned about our H-bridges just earlier. This is going to send them forwards and backwards. Okay. Once you've got this moment of truth to see if your circuits have been wired up, you can run your simulation. Okay, so that means I'm going to just zoom out here. If I haven't wired this up, I'm going to hate myself. Right, so there you go. So you see our motor spinning, and upside down here, you can see minus 143 RPM and positive 143 RPM. Okay, so that's it spinning one way, and then it's spinning the other way. And then it's spinning one way, and then it's spinning the other way. And it's just looping this over and over and over again. Okay, and it's running that for a second. I'm going to move on with the theory stuff because we've got stuff going on. PWM. Okay, guys, so I'm just going to demonstrate PWM to you guys. I'm not going to ask you guys to do this because we need to kind of speed up. So the PWM pins, as I said, are marked by this little thing. And to do PWM, instead of digital write, we use analog write. Okay, we label the pin, and instead of sending high or low, we send a number between 0 and 255. 0 being 0 volts, 255 being 5 volts. And any increment between that obviously is respective, 0 to 255, 0 to 5 volts. Okay. So I'm just going to show you what we can do here. Okay, so I'm going to label this int speed equals I'm going to int speed equals pin 2. And I'm going to show you this on one motor. Pin mode speed is an output. Okay, and I'm going to take this one here. Let me delete that wire. No. Okay. So I'm going to take pin 2. I don't know why it's not letting me delete anything. And I'm going to connect it to digital pin 2. Oh, no, I'm not. I'm going to connect it to digital pin 9 because we need a one with a squiggly line by it, guys. Okay, so we're connecting that to pin 9. Okay, so this is all I've added. And we've got a new output, pin 9. Okay. And then in this, I'm going to set my analog write speed to let's say 100. Okay, so all I'm doing here is I'm adding these 3 lines and I've moved 1 wire. Okay, now what this is going to do is it's going to send out, instead of 5 volts, to my control pin here, which on our H bridge here enables this right side motor. Because I'm not sending 5 volts, because I'm sending something just a little bit less. I'm sending 100, not 255. Because I'm sending in a little bit less, it's going to make the motor run slower. Okay, don't ask me why. It's lots of magic. Okay, so now when I start my simulation, oh, it's actually even too low for it. Right, let's try speed 200. Do you think this thing supports? Oh, does it not support PWM?
I don't know.
Analog right. I actually think that this Tinkercad might not support the PWM pin on this. That might be quite a funny little thing. Hold on. Anyway, it's not an important thing, but it just gets us there. Anyway, that would have worked. That's very embarrassing. But in a practical sense, that would have worked. That is where there is a flaw with the simulation. The simulation doesn't account for it, but essentially we would have changed the input voltage here and we would have controlled the speed to this right motor. Okay, so in practical sense, that would have worked. Some helpful bits to know in general in programming. We've done everything to variables. Okay, so we've decided LED, int LED, or my variable is 5. Okay, and you can think of that as we're storing the value 5 in my variable like this. We've got my variable, which is a box, and we've put the number 5 in it. Int my array makes an empty array waiting to be filled. Okay, so int my array 5, we've made an array of 5 boxes. Essentially, it looks like this in a kind of very idealist, like it's in a picturesque way. It's like a metaphor. We've made a box of empty spaces. Okay, and this we can assign values to. So here we use the function int my array. We've made an array, and we've put in the values 2, 5, 3, 10, and 4. Okay, and here we've got these boxes, essentially the array variables now have these values in them. Okay, so now we can store multiple values in one variable name. Okay, so now my array has all of these values in it. We can also assign or check a single entry in our array. So if we write my array 2, we select the 3rd value of the array. So 0, 1, 2. Okay, and so it'll jump along. My array 2 would select number 3. Okay, and the value of my array 2 is 3. Does everyone understand arrays? It's a very, very quick introduction to it. I do suggest you kind of Google these things. Please put your hand up if I've lost you at any point. Anyone understand arrays? Basically store multiple values in one variable name. Okay, silence. I'll take that as good. Serial print is the next thing that we're going to use. Serial print basically allows you to see things. It prints it out for you, okay? And so here we can print out a value, and it will print out the value of that variable. Here we can print out text. If we put in these quotation marks, it will print out the text between these quotation marks. Serial print, if we put an ln here, it'll print it on a new line. Okay, and then we can also put these two together. So just to show everyone, can we all put in serial dot
A.
big.
You missed the A of serial.
Oh, thank you. Yeah, my keyboard keeps bugging out. I think it's capital S as well. Serial dot begin 9600. Can we all type that into our setup, please? This line here. No matter whether or not your motors are spinning or not, we can debug that later. Can you all just type that in? And then down here, can you write serial dot, I don't know if it's capital P, that's my...
No, it's not capital P.
Okay, serial dot print, and then just write anything you want. Okay, like that, semicolon. Okay, you can write anything between these quotation marks. Serial.print, blah, blah, blah. And then when you start your simulation, we open our serial monitor here at the bottom. And can you see that it's printing, hey guys? Okay, so we see that. But the problem is it's printing it all on one line. So to stop that, we're going to put LN here. Okay, serial print line. Now when we start our simulation, it's going to write each one on a new line. Can we see that? And it's doing that every second, because obviously every 2 seconds, sorry, because it waits 1 second here, waits another second, and carries on. Okay, so this is how we can serial print. This is how we can get feedback, read things, okay, which is going to be important for our sensors. Okay, anyone not following the print function? Hands up, please. Feedback, talk to me. Very lonely. No? Okay. Right, serial monitor, as I've explained it to you, we've done the serial print, blah, 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 blah. If statements. Okay, now we're actually getting into some actual logic. Okay, an if statement is very, very important. You'll pretty much see it in any language you use. So here we have the statement, if my value is equal to 10. Notice the two equal signs. We're comparing. It's a comparator, right? If my value is equal to 10, this number here, then if this statement is true, you will execute this bit of code here, okay? Right? In between these two curly brackets. Okay, so if this is true, we execute this here. If it's not, else, so we put in an else. If it's not, otherwise, serial print, my value is not equal to 10, right? So here we're going to put in between these brackets a code we want to happen if this case is not true. So we call this a condition, right? So this is a condition that we're asking. So let's go ahead and copy that in to our codes. Again, you can just put this in your loop, just enter it here. Okay. And then we're going to create a val equals 10. So create a val variable like my val is 10. Okay. And then here I want you to write if, non-capital I, if open brackets my val is equal to 10, serial print my val is equal to 10, or whatever you want, semicolon, close bracket, else serial print, and do this. Okay, can I get a thumbs up when everyone's done that? Okay, so when we start that now, because oh hello, what's this? What have I done? Oh, I use capital C. I think that's my problem. Is that different to that?
I'll say mine is not a name type. Line 11.
If my val is equal.
My val not declared. Up top.
I've definitely declared. Oh, int.
Yeah.
Sorry. Okay. So because we hadn't put an int there, we hadn't actually made that variable. So we're going to start our simulation. Check our monitor. My value is equal to 10, and because we haven't put a line here, it's going to print onto the same line as hey guys. Okay, so you should all be seeing something like this. And now if you stop the simulation and change your value to anything else, it checks that statement and your value is not equal to 10. Hey guys, apparently. Okay, so this is an if statement. Very, very important to know. Please can everyone let me know in the comment section if you got the if statement to work. Now we're going to do the else if statement. What? Mind blown. What could this mean? Sticking to our same statement as before. If my value is equal to 10, then serial print this line in between these brackets. Now, instead of going straight to your else statement, instead of saying if it's this, do this, otherwise cut to our it's not 10, we can do another check within that. We can say otherwise, if this condition isn't true, if my value is equal to 11, for instance, serial print my value is equal to 11. Okay, and you can do as many else ifs as you want. So you could do is my value equal to 10 and all the way up to 100. You could whack in loads of these else if statements and you could make it really specific. So you could find out exactly what your number is, what my value equals. Okay, we're not going to do this because it's pretty trivial. It's scalable. Also some useful operators. I've been showing you this one, which is equal to. You've also got not equal to, which is just explanation in front. Less than or equal to, general maths, greater than or equal to. And we're not going to get into Boolean just yet because that's a whole different kettle of fish. Okay, before I lose you guys, I want to finally get you guys just reading some sensor values. Okay, so bear with me. If you do need to go, then obviously go. The rest of this will be recorded on YouTube. But if you do want to learn how to read a sensor and apply it, please stick around. Okay, so reading our inputs off our sensor, we're going to use an ultrasonic sensor. Okay, ultrasonic sensor basically looks like this little doodad up here. It fires out a signal from one of its eyes. It looks like two googly eyes. It fires out an ultrasonic signal from one of its eyes. That will bounce off an object if there's an object around. And that will land in the other eye. Okay, it's basically echolocation. It's yelling and waiting to hear when that comes back at you. So here we have our 4 pins. Okay, we've got our 4 pins of our sensor. The red one connects to 5 volts VCC. The black one connects to ground, okay, on our Arduino. So you can see red and black here connected to our Arduino. The yellow and green. So the yellow one is our trigger. Our trigger is setting the sensor off, sending out that signal, triggering it. The echo is waiting to hear back that signal that we've just sent. Okay, so this is how it actually works. We send a small little signal, bam, we set off the trigger for, I think that's 10 microseconds. We send off our trigger pin, yeah, that's it, 10 microseconds trigger pulse. Then it will send out a signal, it will send out an ultrasonic signal. And then on the echo pin, we wait to hear that back. Okay, so that's the logic behind what we're doing here. Now I'm just going to pull up my cheat sheet because I want to make sure I get this right. Don't look at it. Don't look at it. Okay. Fantastic. So now we're going to go back to Tinkercad. And for this, I would like you guys to, what's probably easiest? Yeah, let's grab another breadboard, another Arduino, because otherwise it's going to be a right faff. So grab yourself a Arduino and breadboard from this list over here and bring it over. We're going to start this real quick. We're only going to connect up an ultrasonic sensor. Actually, in fact, I don't think we even need the breadboard. No. Let's just get a second Arduino. Get yourself a second Arduino. Just type in Arduino. Grab it. And then once you got that, oh, I'm not typing it in. Stop my simulation. Type in ultrasonic. Okay. One thing I want you to pay attention to is there is 2 on here. We're going to use the one with 4 pins. It's the more traditional, conventional, cheaper. Brez buys the cheaper ones. So we're going to grab this one. You're going to whack it in. And you're going to show like so. Okay. So what we're going to do is we're going to take the VCC, our power. It literally tells us what that pin is. Okay. We're going to take that and we're going to draw nice straight lines, people. We don't like these disgusting You can obviously connect, it snaps to place. If your lines aren't straight, then you can get really jazzy like this. Okay, we're going to connect that one with a red line to our 5 volts. We're then going to take our ground, and we're going to connect that to our ground pin. Okay, and we're going to neaten up the cables, and we're going to make that black. Okay, all happy? We're then going to take our trigger, okay, trigger fingers, and we're going to connect this to any digital pin we want. I'm going to connect mine to 7, just make a note of which one you connect. And I'm going to connect my echo to pin 3. Okay, and then I'm just going to color them so I know which one's which. Okay, so just connect that up to any 2 you want. Because you've got a second Arduino, I need you to make sure that you've got your Arduinos properly chosen, so Arduino 2. If you don't know which one it is, it should say R3. Anyway. Okay. So what we are going to do now is delete all of this that I don't know why I've got here. Okay. And we're back to our setup, our loop, and our blank bit for our declaration. So the first thing we got to do, can anyone tell me?
Declare the sensor.
Declare variable.
Declare the variables. Right, okay, so we're going to type int. Thank you, guys. That's what we like. And I'm going to call that trig pin. Okay. You can call it whatever you want, whatever's suitable. And then make a note of which one your trigger was connected to. Mine's the green one, connected to pin 7, semicolon. Int echo pin, pin 3, semicolon. Okay. Everyone good with that? In our setup, we're going to open up our serial print again. So serial dot begin. Now, you've either all seen this before or you're all too shy to ask me, why are we typing in serial begin 9600? Anyone curious?
With the higher baud rate?
It's the baud rate, right. So basically, we're setting up our serial communication. This is our serial. It's like USB, universal serial bus connection between our Arduino and our computer. We're starting that. We're beginning it. And this is the data rate. This is the rate at which data is coming in. You have to have this the same as your board, right, which is usually standard 9600. Okay, so once we've got that, we are now going to do what, people?
Pin mode.
Pin mode, right, exactly. We've got to tell the Arduino what we're connecting. Is it an input or an output? So pin mode. Oh, I put a capital O there. Pin mode. And come on, you guys, you should all get this by now. We're going to put trig pin. Trig pin is, because we're sending a signal to our ultrasonic sensor to trigger it, is an output. And what do we think echo is going to be?
Input.
Input, right. There we go. Thank you. Right. Come on, guys, don't be shy. There are no wrong answers. We'll only laugh at you for a little bit. Come on. So trig pin is our output. Echo pin is our input. Can I please get some responses from people if I am losing anyone, if you're so confused what I'm doing, or if I'm just being really patronizing? All right. And then we are going to now write what we call a function. Okay. Now I'm just going to demonstrate a function to you guys. So keep your code here. Keep your code here. But now a function, right? Functions. Instead of just having our loop, we can now jump out of our loop to another function. The same way that we have our setup function and our loop function, we can create our own. Okay, this avoids having to repeat code. So let me demonstrate a function to you really quick. I've got a pre-written code, so I'll just copy and paste it. Okay, let's take that. So stay where you are, leave your codes in your boxes. I'm going to want to copy and paste that, aren't I? Okay. Right. So this is an example of a function. Here we have our declaration. I've made a value called 10 or the value of 10, and I've got a result. Here in our setup, we've started our serial begin, and then I've got a function. It's going to return an integer function, and I've put in a variable. Okay, this is something new, so don't worry about this just yet. Okay, so let's ignore this for a second as if it's not here. We've got our loop. Okay, so it's going to go from setup to loop. Result equals function. So we're going to now go to our function. We've called it, and we're going to put in value. Value is currently set to 10. Okay, so result is equal to function, this here, inserting our value of 10. Okay, so here we're going to jump to function. We've inserted the value of 10, which we've called var1. Now, our new variable int var_out is equal to var1. Okay, var1 plus 1. Okay, because we've all entered our value of 10, var1 plus 1 is going to equal 11. Okay, then we're going to return var_out. Okay, this might seem like a big step, but you can kind of see the logic. We're going to return this as a new value. We're going to return that number plus 1. Okay, we're then going to just jump back to our loop because function has reached the end of its line. Okay, it's reached the end of the function. We're jumping back here. We're back in our loop. We're going to print out our result, and then we're going to assign value equal to result. Okay, so when I run this, what you should see is the number just constantly increases. Okay, so the number's just constantly increasing. The reason it's doing that is because if we just start again, value is 10. We've got our serial begin. We don't really care about that. We know it. We go void loop. This is going to happen over and over again. Result is equal to. Okay, and when we've returned var out, this function has returned var out. So when this equal is now equal to var out. Okay, and we've done the calculation for that here. Is anyone confused by what I've just said here? It's quite a lot of information just to suddenly take in. But essentially all we've done is we've created a system whereby we take in our value, we add 1 to it, and then we return it back to our loop. And then we print it out, we store it again, we send it back to our function that adds 1 to it, and we print it back out. Have I lost anyone? Does anyone want me to go over this? Any questions?
See how you have declared var1 inside the function.
Yeah.
So could you use var1 in loop, or is it just for that function?
No, so this var1 is now only for in here. Okay. So var1 is only used in function. You can't suddenly now I can't now write var1 equals, I can't do that because it doesn't recognize var1 in the loop function because I've just called it in here. Okay. And I can give this any name I want. So the function here, when I call the function, it basically wants a variable. It wants an integer to be given to it, which is what I've done here. Okay, I've given it the value variable, right? But it could have been anything. I could also call this var100. I would just have to make sure that I use var100 in there. Okay? Yeah, okay. It's the same thing. Okay? So
excuse me.
Yeah.
I was wondering if this code, the first number of this code will appear 10 or 11. The first number appears.
Oh, so the first number appears as, which I would expect it to be 11. Oh, I don't know why it's 8. That doesn't make any sense. So I think that's from a previous. Oh, because it stops recording for a certain part. So if I start this, the serial monitor will only store so many values. So I need to start it and stop it really quick.
It depends at the bottom, so you only have to scroll up a bit.
Okay.
No, too much.
Yeah, so there you go. There's the first value, 11.
Okay, I see. Thank you.
Because it takes in the value of 10, passes that into our function. That function then takes it to be value var100, does a little computation where it does var out is equal to the value we've given it plus 1, and then outputs that. Okay, which is then made equal to our result, and then we just print it out. Okay, is everyone happy with functions? Anyone not happy with functions? I need you to get this because we're going to add a lot more functions later on. Okay, right, we're coming close to the end of the time, so back to our sensors. If anyone has questions about any of this later on, I'm more than happy to stick around and ask your questions. Let's just get this all done quickly. Right, so we're back to here. We're looking at this. Actually, can I get this done without a loop? Would that just save so much confusion? Yeah, all right, let's just do that. Okay, so what we're going to do is we're going to do digital write. So firstly, we have to do this pulse, okay? We have to basically send out this pulse, this trigger pin pulse, okay? This one here to trigger our sensor. So we're going to write digital write, and we're going to set trigger first to low. We're going to clear the trigger pin. We're going to make sure there's no signal on the trigger pin. And we're going to give it a delay. Okay. But this time the delay is in microseconds.
You missed the M.
Yeah, I think that's my keyboard is really, because it's wireless, is really, really lame. Delay in microseconds, that should be a capital M. Okay, and then we're going to add in 2 microseconds, very, very, very short time. Okay, and this is just, I'm going to add a little comment here, clears the trig pin. Just make sure that that trig pin is low, okay, because we only want a 10 millisecond trigger. We're then going to write digital write trig pin. No one's called me out on this. The variable was called trig pin. So that needs to be called trig pin. Okay, it's because I'm copying from another piece of code. We're then going to set this to high. Okay, and again, delay microseconds. This we're going to send high for 10 microseconds. Okay, and then we're going to set it low. Okay, so all this code does, right, all we've done here is nothing fancy new. All it does is create this pulse for 10 milliseconds, microseconds, sorry. Okay, it just creates on and off. That's fine, Deniska. We'll put this on YouTube and you can keep up them. Literally just closing up. Okay, so we're just creating that pulse for those 10 microseconds. And then once we've sent the pulse, we need to listen on the echo pin. Right, so we're going to create a value, and instead of integer, we're going to use the value long. Not going to explain that. Long distance. Okay, our distance is going to be equal to the duration of pulse in. So that's reading the pulse in on our echo pin. Okay. And we're waiting for it to go high. So I could have explained this function here, but pulse in basically waits for a pulse in on this pin and waits for it to go high. Okay. And then we're going to do distance equals distance times this magic number 0.01723. Don't forget your semicolons. Okay. And then finally, that's the last line. We're going to serial print out our distance. So all we've done here is we've cleared it. We've made our 10 micro pulse.
That's 10 mega.
Yeah, I know. I just couldn't be bothered to type micro. And then we are waiting for the pulse, back. We're then converting it to distance by multiplying our value by this magic number, and we're serial printing it out. Okay, so if God is good, when we start our simulation, Okay, we can now click on this sensor, and you can now change the values coming out. I don't know why it's not. Okay, and there you go.
Yeah.
Okay, so now you can see this. Okay. So sorry about that. Just make sure you've got the right Arduino. Make sure you don't delete the Arduino with the code on it, because I deleted the other one that did have the code on it, which obviously was the wrong Arduino. Anyway, so maybe just switch between your Arduinos here, copy and paste your code in. Okay. And that is how we're going to read ultrasonic sensors. Now, next week, we will be doing something like this. I will finish off, obviously, what we needed to learn, but I'm just going to show you. We'll be doing something like this. We'll be programming this little robot to solve a maze, just so that you guys can see what this should look like. Okay. We might not get all the way through it, but we'll try our damn hardest. Okay. Anyway, just wanted you guys to see what we'll be doing next week. So yeah, can anyone tell me if they get this working? So guys, I think that's everyone that's got it. Well done. Once Olivia has figured out the little bugs in her code, and then let us know, Olivia. I want to make sure that everyone's got it. The final thing we were going to do, guys, is basically fuse the two sections that we've done today. Okay, so we've learned how to control the motors. We've learned how to read the inputs. Yes, Olivia, yes. We've learned how to control the motors. We've learned how to read the inputs. Now we need to put them together, right? So when an input on the front triggers and all the rest. So what I will cover at the beginning of next week's session, if you guys are happy for me to do this, is how to do multiple sensors, because we've just done it with the one. How to do multiple sensors, and then how to use the sensors to control our motors, and that will involve if statements. Anyway, thank you all very much for joining. I hope you've enjoyed the session. If anyone has questions or wants to ask more about where Fundamentals is headed, or something you would like to learn, 3D print, please do stay around and let me know. Otherwise, you're free to go. You're released. Yeah, have a great evening.